Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter Work and Energy 9 Cbse. So last time we did what is energy, what are the unit of energy, and the relationship of energy with the height and potential energy and kinetic energy relationship. Today we are going to see few more activities and we are going to see what is kinetic energy all about. Now let's see another activity. Place a wooden block of known mass in front of the trolley at a convenient fixed distance. Right. See here. See the arrangement. Trolley is there. A wooden block is there. Okay. Right. Two wooden blocks are there. A pan is there in which you have put a mass. So what we have done, we have placed a wooden block of known mass in front of the trolley. Here we have put. Okay. Then place a mass on the pan so that the trolley starts moving. Now the trolley will move. Right? The trolley will start moving. The trolley is now moving. Fix a stop on the table in such a manner that the trolley stops after hitting the block. Right? The trolley will now hit the block and it will stop. The block gets displaced. So the block will get displaced. It will move. Right? Okay. Note down the displacement of the block. This means the work is being done on the block by the trolley. Right? As the block has gained energy. Okay. What has happened? The trolley has done work on the block and the block after that it possessed energy and the work has been done on whom? The work has been done on the block. Right. Let's try to answer few of the questions based on this activity. From where does the energy come? When a mass is placed on a pan, it exerts a force F on the trolley. Right. And the trolley starts to move. What we have done? We have placed a mass. Where we have placed a mass on the pan. The moment we put, what happens? The force was exerted. The force F was exerted on the trolley, right? And the trolley started to move. The kinetic energy is transferred to the block. The kinetic energy was transferred to the block. The kinetic energy is due to the change in the potential energy of what? Of the pan, right? And the mass system. Because we have put weight, okay, the mass in the pan, because of that what has happened? The kinetic energy was generated. Okay. Repeat the activity by increasing the mass of the pan, in which case is the displacement more. What do you feel? When the displacement will be more? When the mass will be more. When the mass is increased in the pan, this time more potential energy is converted into kinetic energy. Means mass is interdependent on potential energy. Right? So more the mass, more is the potential energy, and more is the potential energy. What will happen? More the kinetic energy will be generated. So the trolley hits the block with more force it hits, and block gets displaced more. Alright. So in this activity, the moving trolley does the work and hence it possesses energy. Alright. In the second situation, more work is done because both force and displacement are more in the first situation. Right. So as compared to the first situation, this activity shows that due to much energy in the moving body causes more work done. Right. More the energy, what will happen? More will be the work done. Right. Okay. Now let's see what we understand by kinetic energy. Objects in motion possess energy. Okay, moving object, you are riding a bicycle. The bicycle is in motion. Okay, so what energy it is possessing? It is possessing a kinetic energy. Alright, a ball is moving, it possesses a kinetic energy. Okay, arrow is moving, it contains a kinetic energy. Okay, you have thrown an object from a distance and the object is falling down, so that object contains kinetic energy. A speeding bike, a bike is speeding, so which energy it will contain? It will contain kinetic energy. Then a rolling ball will be there, a flying aircraft, okay, flowing water, blowing wind, a running athlete, all these possess what? A kinetic energy. Okay, in short, a kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. Right? So how the kinetic energy increases? Due to its motion is there. Right? So as the speed increases, the kinetic energy also increases. So kinetic energy increases with speed. The kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire the velocity. Okay, so now what we are going to see, we are going to derive expression regarding this. Okay, regarding the kinetic energy. So for that, let's consider an object of mass m moving with a uniform velocity. Okay, I have got an object of mass m. Let me write. Okay, we have got object of mass m is there. Okay, here mass m is there. Then I have got a uniform velocity, initial velocity u is there. Then a distance of s is there with a constant force f acts on it, okay, in the direction of the displacement. In the direction of the displacement means a positive work. The work done is nothing but, we know that work done is force into displacement, right? The work done on an object will cause change in its velocity. As the work is being done, what will happen? The change in velocity will happen, right? Let the velocity change from u to v. So v is what? My final velocity, u is my initial velocity. Okay, then what will happen if the velocity changes? Velocity changes, acceleration is generated. So a is the acceleration produced. Okay, we have already studied the three equations of motion, the relation connecting the initial velocity and the final velocity of an object moving with a uniform acceleration a and the displacement s. If you remember this, so what we had v square minus u square is equals to 2as. Right? So this equation we all remember. So if we rearrange, so what we'll get? S is equals to v square minus u square upon 2a. Okay, and we know that force is nothing but its mass into acceleration, right? So the work done by the force, work done is nothing but force into displacement. So what you need to do, put the values of force. Force is nothing but mass into acceleration, and put the value of s, what we got. Okay, so we have put this. Then what will happen? If you see this a is common, so this a and this a will get cancelled, right? And if you rearrange this, then what we'll get? W is equals to half into m v square minus u square, what we'll get. Okay, now you'll see that if the object is starting from stationary, now the object was placed here, it's stationary, okay, right? So the position, the value of u will be 0, the value of u is 0, right? So therefore what we get is w is equals to half mv square. So from this it is clear that the work done is equal to the change in the kinetic energy of an object, right? So if u is 0, the work done will be 1 by 2 mv square. So the kinetic energy possessed by an object of mass m moving with a uniform velocity is nothing but is Ek 1 by 2 mv square. So this is the expression for kinetic energy. Let's see an example. An object of mass 15 kilogram is moving with a uniform velocity 4 meter per second. What is the kinetic energy possessed by an object? So what is the kinetic energy possessed by an object? What we need to do? First of all, what is given? Mass of the object has been given 15 kilogram. Yes. Velocity of the object has been given 4 meter per second. Right. And what has been asked? We have been asked the kinetic energy. So kinetic energy is nothing but 1 upon 2 mv square is the formula we need to put. Right. So we have 15 kilograms. The mass has been given v square. So we have written twice this 4 meter per second and 4 meter per second. Then what will happen? Anja, 2za, right? Then 4 2za 8. 8 into 15. So the kinetic energy of the object is 120 joule. Student, I am sure you have understood today's concepts. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala.